friends, I'm Giridhar from Mechanical Engineering, GCT second year. Today we're gonna see my IPL presentation in the subject kinetics of machines. My topic is cone clutch. What is clutch? Clutch is a mechanism for connecting and disconnecting an engine, drive, and the transmission system in a vehicle or the working parts of any machine. It allows a temporary separation of drive between the drive source and the driven mechanism. When engaged, this will allow a smooth take-up of drive as the clutch is gradually integrated. Cone clutch. A cone clutch serves the same purpose as a disc or plate clutch. However, instead of making two spinning discs, the cone clutch uses two conical surfaces to transmit friction and torque. The cone clutch transfers higher torque than plate or disc clutch of same size due to wedging action and increased surface area. In this figure, the driving shaft and the friction lining and the driven shaft of the clutches are shown, where alpha is the cone angle and W is the work input. Only one part of drive assembly is possible, that is N is equal to 1. This is the ideal diagram of cone clutch, in which there is a driving shaft present and a driven shaft present. Therefore, the driver and driven is also present, and a conical friction surface is present. Spring is present. These are all available in the general cone clutch. So, let us here B, alpha, R1, R2, P and W are used for deriving the formula for cone clutch. Assumptions, that is the for finding the formula, there are certain assumptions which are given by Pn is equal to pressure intensity with which the conical surfaces are held together, that is the normal pressure between the contact surfaces. Rn is the outer radius of the friction surfaces and R2 is the inner radius of the friction surface. Capital R is the mean radius of friction radius, that is small r1 plus r2 divided by 2. Alpha is the semi angle of the cone, which is also called as phase angle of the cone. It is the angle of friction surface with the axis of the clutch. So this is simply the angle of friction surface with the axis of the clutch. And mu is the coefficient of friction between the contact surfaces, and B is the width of the contact surfaces, which is also known as phase width or clutch width. Considering a small ring radius of R and thickness dr, we get sigma A is equal to 2 pi r dr divided by sin alpha. The normal force between the cones, that is sigma A dot P is equal to 2 pi r P dr divided by sin alpha. The friction force is given by 2 pi mu r into P dr divided by sin alpha, and the friction torque is given by 2 pi mu PR square divided by sin alpha, from which Mt is equal to, for integrating the previous equation, the torque and the axial force to increase clutch is obtained as Mt is equal to 2 pi mu divided by sin alpha into integration of PR square dr over the limits small r to capital R. Finally, we get the force as 2 pi integral of small r to capital R PR dr. Now the area of the ring is, we know that area is equal to 2 pi r into the circumference into length, that is 2 pi r dl, which is equal to 2 pi r dr cosecant alpha. We shall consider the following two cases when there is uniform pressure and when there is uniform wear. When there is uniform pressure, the pressure is constant and there is the wear changes. Therefore, F is equal to pi dot P into capital R square minus small r square, and the torque is equal to 2 mu F divided by 3 sin alpha into capital R cube minus small r cube divided by capital R square minus small r square. According to the uniform wear theory, where the pressure into R is constant, that is pressure to radius is constant, the force is given by F is equal to 2 pi PAR into capital R minus small r Then torque is equal to mt is equal to uf into capital plus mother divided by 2 sin alpha. The following points may be noted for clutch. The above equation is valid for steady operation of cone clutch and after the clutch is engaged. If the clutch is engaged with one member is stationary and other rotating, the cone faces will tend to slide on each other due to presence of relative motion. Thus, an additional force acts on the clutch which resists the engagement, and the axial force for the required cone surface increases. Under steady operation, a decrease in semicone angle increases the torque produced and reduces the axial force. For the cones having uniform pressure and uniform wear. Applications of cone clutch. Cone clutches are generally now only used in low peripheral speed applications, although they were once common in automobiles and other combustion engine transmissions. They are usually now confined to a very specialized transmission in racing, rallying, or in extreme off-road vehicles, although they are common in powerboats. Thank you. That's it, my content for CLTUCH.